again. So we had to take a little bit of time off because it was a little bit too cold and a little bit too cloudy when we first set this up to be able to actually do anything with it once we did set it up last time. So I've set everything else up again, and so now I'm going to go through how to use this telescope in order to find things. So have it plugged into a battery pack. You can pick these up fairly cheaply at certain places. This one was only around 50 bucks and it's actually pretty good. Have it plugged in. We're going to use the computer now, so we're going to get this set up. There is a little bit of a initialization that you have to go through here, so we got to wait for it to start up. You should hear the engine or the motors kick on, and once it gets through, probably right there, you can pick up the hand paddle. And then what we're going to do is we're going to first get it set up with a time and date. So we're going to hit enter. It's going to tell you never look at the sun. We're going to set our longitude and latitude, and if you have a cell phone, you don't even need a GPS device because you can download an app in most cell phones that tells you where that is. So I'm going to do that pretty quickly. This one's called GPS status. You can use whatever one you want. So our longitude right here is 111 west, 111 55 51. So in here it doesn't give it that fine, so you do 56, just kind of round up, then hit enter. Then we're going to set our latitude. I'm going to do north 40 45, enter again. Time zone, you can use daylight savings or not. You just have to specify whether or not that it is daylight savings later on. So right now we're going to do -7 because we're in the mountain time zone. We can do our elevation here. Our elevation is 1290, 1300 meters. Got to give it a few seconds to level out. So positive 1300 meters. And you can change your app to read whatever you would like. You can do decimal places for your longitude and latitude, hours, minutes, seconds, all those kind of things. It gives you your latitude and or your altitude in meters, or it can give it to you in feet, whichever one. This thing here, this particular telescope is using meters, so you don't need to do any conversions. You just got to set it up right. And today is, let's see, April 18th, so 04/18/2020. Set that in there. Our time on my phone is going to say 9:09, but that's assuming that you are in daylight savings, so it should be an hour different. So I'm going to set that. And then if you set it right, it'll tell you the time, and it should match up with your phone or other device that you're using, depending on if you're daylight savings time or not. Okay, so once we get all that in there, we're going to hit there. Daylight savings time, no. Polaris position, it's going to read that off just to let you know in what orientation you need to turn the telescope to be able to find Polaris in the right spot in the sky. But we're going to do it a little bit different, so we're going to hit enter on that. Hour angle is that. Begin alignment. We don't want to do that quite yet. We want to make sure that our telescope is aligned to the North Polar Star a little bit better than what we have when we set it up during the daytime. It's the easiest thing I've found to do that for, is to pop that off. Some of these do have little caps. You can take that off of there. And there's sometimes a cap up here you have to remove. And then most of the time it's a straight look through. Some of them have a bar in the center that take up that space. But using our trusty laser, we're going to make this 1,000 times easier than bending over and trying to look for it. So we're going to use our laser to find Polaris. And we are really far off today because I didn't care to set it up like I told you to in the video. So we're going to spend a little bit of time moving it. back and forth. So I'm going to use the north east-west movement things there to get that. We're pretty close right there. It's kind of some branches in my way, but I can go around it a little bit. There we go. So now we have to go down a little bit. So then you use these two. That's the wrong direction. Loosen that one and tighten that one. So that gets us pretty close. And for visual observations, you don't need it quite as centered with the North Polar axis as you would with astrophotography, because these computers, they all have a pointing model that are built into them, so that'll help, and that's what the alignment is for. Okay, so what we're going to do next is we're going to go through a star alignment with this telescope. So when you're doing this, you have to be sure that you're using a wide enough field of view with your eyepiece that you can actually see the stars fairly well. You also want to make sure that your finder scope is aligned properly, and that's something you can do during the day. Probably do that in a later video for our next telescope. But this one should be fairly aligned. We're going to do that really quick at night though, and we'll do that on our first star, and I'll show you how to do that pretty easily. So even if your finder scope is off, using that little laser trick, you can actually do it pretty easily. So we're going to say begin alignment, number 1 for yes. We're going to do a 3-star alignment. That gives you the most precise offset for where you are relative to the North Polar axis and to the mount position. That way it goes to your next objects really easily. Alright, so we're going to do a 3-star line, hit enter. And we're going to pick 3 stars that are up and that are able to be seen really easily right now. Sirius is behind that tree and house, so we can't use that one. Arcturus is visible, so we will use that one. If you're having a hard time picking out where these are, you can use your phone app, and that'll help you figure out what part of the sky they're in and how bright they are and where you should be pointing. So we're going to do the first star. We're going to hit enter. The telescope is going to go where it thinks it should be based on how you set it up initially. So if you set it up perfectly, then it should go right to it, but most of the time you won't, and so it'll be a little bit off. So Arcturus right now is in the east part of the sky, and it's pretty far off where it actually is. So we're going to use our laser trick through the telescope eyepiece. You should be able to see this still. If you have one of those really bright green lasers that you can pick up on the internet for under $20. So now I'm going to switch to a faster rate because we got to go pretty far. So using the laser through the main tube gets you really close. You can actually get it within your eyepiece just with the laser there. So now what we want to do, we want to center it up in your eyepiece. You probably want to slow down your rate so it makes it easier. That way you're not having to jump around so much. And then we're going to check the alignment through the finder. And this is a great time to do this since you're at a place you already know. And if it's nighttime, then it makes it super easy. And if you take your finder scope off properly, it always is going to be pretty close to where it should be. Okay, we're going to focus just a little bit. And it's pretty close into the center. So I'm going to hit enter on that. And we're going to choose a second star. And the farther away you make these stars, the more precise basically your triangle in the sky that you're going to build, and it's going to give you a lot better precision at going to your next objects following up this. So the next one is going to be Duba, or Dubhe, or however you want to say it. So we're going to hit that, and it's going to go to where it thinks it is based off of our new position that we just input. Still going to be pretty far off though. And so if you're not sure where Dubhe is, you can pull up your app again, and you can pick out which star Dubhe is. I'm just going to do that real quick just to show you. And if you can see this, it's going to be the end star in the Big Dipper's handle, or the Big Dipper's dipper. And it's also going to be the brightest star in Ursa Major, because it's Alpha Ursa Majoris. And so we can use our nifty laser trick again and go through the finder scope this time, and we're just a little bit off this time. Hit that speed up a little bit more. So we get it pretty close to there. Take our laser out, put our eyeball on here again, and just center it in the eyepiece once more. Change your rate so you're not hopping around so much trying to figure out between which gears you are stuck in. Once you get it in there again, hit enter, and our third star, I tried choosing Sirius, but that's not up for me right now. So there's Mabsuda, Maz. Find an easy one. You can see where Rukba is. I always forget where that guy is. So you can use your app once more. And sometimes they're spelled differently depending on which app you're using, or it's not even available. Let's try Algiba. Okay, so that one's going to be in Leo. That one is up there. So let's use that one. So enter. So that one is Gamma Leo. No, not Gamma Leo. Okay, so this one should be fairly close, since it already has a pretty decent idea of where things are, but still not in there. Turn our rate up some more. We get it close, and we're gonna turn our rate down. Okay, and then enter, and it says alignment may be poor. The value of the previous North Polar error is applied. So it thinks the elevation is off by 12 degrees, and its azimuth is off by 23 degrees based off of that. So I might not have been looking at the North Star, but I thought I was. This tree makes it hard. Yeah, pretty sure that's the North Star. It's hard to tell sometimes in light polluted areas. So we're just going to deal with that and fix it when we do this again sometime. All right, so now that we have this pointing properly, we can test how good it's going to be by picking an object in the sky. We can try something like Venus again, like we did with our last one. So with this one, you want to hit the planet button. Oop. Got to get out of all of that. And there go planet. Scroll down to Venus. And let's see how close we can get it. So you'll see how this one moves. It'll come back and over like this and point in this direction after tilting this direction. It's going to be a little bit different than like a fork mount or a Dobsonian would give you, but I don't know, that looks a little bit off. We might have to do some things again. Yeah, something went funky there. Okay, so it thinks Venus is way too far north and way too far east right now. So let's try to do something like Mizar and Alcor to check.
Let's see. So we go to skip out those, object, name stars. Let's try Alcade.
So if it goes to Alcade properly, that just means that something with our time or location is messed up. Maybe I didn't input it quite properly enough. But if it does go to Alcade, or if it doesn't go to Alcade, then something else is wrong. Yeah, it's way far off from Alcade. All right, so that means we're gonna have to restart and try this again. So just kill it. Put this back in your home positions. We'll check everything once again. Okay, make sure that's like there. Make sure this is right there. Should be pretty close. All right, let's try round 2 of getting this thing working. Power on. Enter. West 111.56. We'll check our longitude again. (111.56). Good. 4042 north. Time zone. We'll say -6. 1300. 4/18/2020. April 18th. Yup. Time is 21:30. 9:30 p.m. Daylight savings. Yes. Okay, that could have been the problem. Okay, let's try this again. We're going to go through 3-star alignment. See if it'll give us the same stars again. Saginas, Minkar, Absuda, Maz, Farud, Algorab. Try Algebra again. Okay, still pretty far off, but not too bad. Change our rate to a faster rate.
Get that centered up again. Okay, once that's centered, hit enter. Put Arcturus next.
Maybe I was on the wrong star, but that's not Arcturus. Okay, we got some fresh batteries in the camera. We were at Arcturus, and so now we're going to find a third star. Hopefully I didn't mess this up for the second time. This star happens to be right behind the tree. Should have checked that first. So it looks like we're going to have to start over. Okay, round next. 3-star line. Let's just go to Arcturus first. Always start with a star that you know is the right one. Let's go to Regulus. That's a good one. Easy to find star in Leo.
Pretty sure that's Regulus. I'm gonna double check. Yes.
That is our friend Regulus. Okay, can't go to Sirius. Surprise, right behind that tree, I'm pretty sure. Yeah, that's way far down. Where's Capella? It's probably over in the east. Oh, we can go to Capella. It's there in the west, so let's go there. Okay, there's Capella. Good enough. Alignment successful. Value of it is 1 degree azimuth and 1 degree elevation. Not bad. Okay, so did that. Now let's try to go to Venus. Planet. Venus. Enter, 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 go. Figured there was something wrong last time. Pretty close. And there it is. It's super bright. I'll snag a picture with my phone. Man, that is so bright right now. It's crazy. Switch to Pro mode. And then you could make the exposure much shorter so you can actually see it. And snap a few pictures. There we go. See that? That's Venus through a camera or phone. Voila. There you go. Now if we want to be able to zoom in, you can change out your eyepiece. I had a 40 millimeter in there initially. So now we can switch it to a 26 millimeter, which will zoom in. So the lower the number, the higher the magnification that you're going to be viewing at. But also the smaller the field of view. So keep that in mind. That's why we use a 50 millimeter or a 40 or 32 to be able to find things. And this is so bright. It's actually feels like it's as bright as the moon right now. And we can zoom in even farther if we go from 25 to a 17. I'll switch those out real quick and center it a little bit better. So since it's so bright, we can actually add a filter on to take some of that brightness off. And we do have some hidden away in the depths of our boxes. I'm going to try to do this in the dark. So this one is an Orion number 95, which means it's a neutral density filter. So it's going to knock down that brightness. That way it's not overwhelming your eyeball. So now when you look in there, it should appear a little bit dimmer. So that one's not bad. Let's see what else we have. You always want to put your filters back in their cases, just so you don't drop them, step on them, or get dirt all over them. Looks like this one's like an orange filter. Switch that out, and these just go in to the bottom of your eyepiece, screw right in there. Yeah, that one doesn't help us at all. Sometimes people say that using the right filter, you can see different features on Venus and other planets. But I think they might be crazy. It's going to be like a greenish blue. This one is Orion 80A blue. So let's see what we got. So this actually does work on planets like Mars. So like blue filters will help make the polar caps a little bit more visible. It looks like we might have a little bit of issue with our optic alignment in our telescope, so we might try doing that really quick, or we might make another video out of it. It's probably best for another video, but we can do it really fast. So that is as simple as defocusing. That's pretty close. If you're hearing cats fight in the background, that's just the nightly battles that we have in suburbia. Okay, that's a little better. Oh yeah, that makes a big difference. Still off just a hair. Could be my eyeballs though, but I doubt it. Okay, so we've spent enough time on Venus. Let's try something else. So last time we did M3 with the smaller telescope. So we should try that again. So we're going to hit Escape. M for the Messier object, 04. Enter. Oops, 03. 03. Enter, enter, and go. We'll want to switch out to our other eyepiece because it will be off by a little bit. So we'll go from a 17 to a 26. Let's see how far off we are. There it is. And it's in the field of eyepiece field of view. Now, if your optics are sharp and your skies are dark, which my skies are not very dark, you should sometimes be able to pick out individual stars in that. Center it up, and sometimes if you zoom in a little bit, you can see them. Switching eyepieces out. Looks like it's focused, but not too focused. And kind of pick out some individual stars. I wonder if this is going to come out on a fin. Do a short long exposure. High ISO. It's going to be a little bit more difficult because there's very little light in there. Take a handheld 4-second picture and see how terrible that comes out. Yeah, that's bad. It's not too bad. It's a little, you can tell we're looking at a globular. Try a 10-second handheld on a telescope. Yep, it's there. That's funny. Let's center it up a little bit. Yeah, well, it's there. If I wasn't holding on to it, it would work. Not bad. So that's M3. Let's see what else we can find. So just using our apps right here. Let's see if we can see the guitar or cigar galaxy. So that's M82. It's going to be right above us. So him. Escape. 8-2. Enter. Switch out eyepiece. I'm going to try to do a 40 millimeter just because it's going to be so faint, it's going to be hard to see if it's too close. So I'm going to turn this so I don't have to bend over so far. Cover your eyes. Undetectable. Yep. Not seeing very much of it all. Okay, so M82 is invisible here. That was worth a try. Something that might be visible though, if it's high enough. Oh, it's behind the trees. M13 is up. It's pretty low. Definitely can't see that one. M87 maybe? Let's see if we can see a bare little dot. M8487. There we go. Oh, it's there. It's just that tiny little blob. If you didn't know what you were looking for, you wouldn't be able to tell it's there. And that's one of the largest galaxies in the universe that we know of. We can hardly know it's there. At least in light polluted sky.